Hey, Jim Bergman with MeasureQuick. Wanted to take a few minutes and go over again cold weather evacuations because we have created quite a stir of controversy online on can you do cold weather evacuations. Everything from have you ever heard of triple evac and done a triple evacuation, or we've been doing this for years and we never had any problems, and basically saying we're full of it. And we could argue all day, but I think it's just better to prove what actually happens when we're in a vacuum. So in our shop here, it's about 67 degrees, and I pulled this system down here, and it's isolated. It's been isolated for about an hour right now, an hour and 2 minutes. And this is a 5-ton Goodman coil, so it's aluminum coil, and it's got 50 foot of 7/8 and 3/8 tubing on here, full line set on here. And right again, we're completely off the vacuum pump. We're at 30 microns. So when I started this Decay here, I was at approximately, let me get my glasses on so I can see, 25.5 microns, and I'm up to 29 microns. So I lost about 4 or 5 microns of vacuum here since I've started the Decay test. So this is extremely dry, clean, dry, and tight. This is what you can do if you use a TruBlue hose and a good vacuum pump. We have the Testo vacuum pump on here. And also just interesting, these core tools are valved off, but they're not capped off. So you can see the core tools are holding real tight too. And these are the AccuTools core tools. So great rig here, doing exactly what it's supposed to do. Really good vacuum we can get at 67 degrees. Now what I want to show you in this is I'm going to take this system and I'm going to break the vacuum. And I'm going to put this sight glass on the system right here on this liquid line. And we're going to add just about 1/4 teaspoon to water into the sight glass. Then I'm going to take this whole rig, it's on wheels, I'm going to roll it outside, and we're going to let it set outside for a couple hours for the coil to cool down, the piping to cool down, and even the water in the sight glass will probably freeze at that point, just like it would on a standard installation. Now let me explain, I'm physically adding water in this thing because I don't have a line set inside and part of my system outside. Let me explain how that moisture gets in the first place. Vapor pressure travels from high to low, just physics, right? So, and to think of it, you take a hot shower, that creates a warm environment, high vapor pressure, and the water condenses on your mirror in your bathroom because the mirror is cooler. This is exactly the same thing that's gonna happen. Well, how's the water get from your shower to the mirror? Well, it travels there by lower vapor pressure near the mirror, condenses on the mirror, and we get liquid droplets on the mirror. Same thing happens in our house. If we have an open line set, vapor pressure will travel in that line set from high to low, so it's going to very quickly work its way down the line set, the humidity will, and it will condense on the cold surfaces on the exterior of the house. So the condenser's outside, the surface valves are outside, maybe you have 6 to 10 feet of line set outside. All that is down at 20 degrees, all that is going to be cold, and all that is going to be your low vapor pressure area. That's where the moisture is going to condense. So if you have that line set open for any period of time, you're getting moisture below freezing that's going to condense on that section of line set. Now what I want to show you in this video is that I can still get a very deep, good vacuum when it's cold out. But what I'm going to do is after I pull that vacuum and we isolate it, I'm going to come back inside and let this coil warm up and show you where that decay falls. So the important thing here is this has been on Decay for an hour. And in 1 hour, we've literally gone from 25 microns to 29 microns. So 4 microns, 5 microns are a rise. I didn't take the decimals into account. But we lost about 5 microns a rise. What I want you to see is that when we do a cold weather evacuation, and I'll leave the pump on, we'll monitor the entire evacuation from start to finish. So you can see how long we evacuated the system, what our vacuum level was, and then what happens afterwards when things start to warm up. And I think it's going to be revealing to you. So we'll go ahead and get started on this, and I'll take you through the next step. So I've got a teaspoon here, right? Not a scientific measurement, of course, here, but it's about 1/4 teaspoonful of water. And all I'm going to do is I'm going to just pour this water into the sight glass. So this is about a drop or two. Let me get it down to the bottom here if I can get it shaken. Some of the water's going out, but just enough that I can get some water in here. I don't care that it's not very much. I probably lost half of what I put in there, but it'll at least get us an idea of how much moisture impacts evacuation. So you can see right now we have about just enough water just to take up the very bottom of that sight glass. So if I tilt it forward, you can see it's barely, the bottom's full. It's just a couple drops. If I tilt it flat, it's just a tiny bit of moisture in there. All right, so we got everything outside now. I'm gonna let this sit for a couple hours just so we can let the line set cool down because it was 67 inside. It is 23 degrees right here in Mogador today, so it is nice and cold, and it's not supposed to get above 26. So this is a pretty typical low weather evacuation, cold weather evacuation if we wanted to do that. So let's give it a few minutes to settle down, and then we'll start our evacuation. All right, so we're out here. It's Blue Vac is saying it's 37 or 34.7 degrees. It's a little bit in the sun, but it's probably closer to 20 degrees out here. I went ahead and hooked up the Testo pump, the 552i, and it's ready to roll. It's warm. I didn't let the pump get cold too. I just sort of brought it out here and hooked it up to the system. So we're gonna go ahead and power this guy up, and we'll see how our initial pull down goes here for just a minute. I'm not gonna stay out here all day because it's cold, and I'd rather not work in the cold. So here we go. All right, we'll give that a couple minutes to pull down, and we'll pop right back into it. All right, so you can see we're coming down now, and we're sort of flattening out here. We're flattening out at about let's get to the micron, about 800. So we're down below 1,000. We're flattening out, and we'll see how it runs for a few minutes. But you can see that we're not quite hitting the 500 mark yet. What's going to happen is this ice is going to start to sublimate. And as it starts to sublimate, if it is ice, we might have just turned to ice because we're dropping the vacuum down. As it starts to sublimate, the ice will actually get colder. And as the ice gets colder, the vapor pressure is going to continue to drop. And we'll see if we get down to our 500 micron level where we normally want to isolate the vacuum and do our decay test. All right, so now you can see we've sort of stalled out. We started this, we're about 15 minutes in or so, and you can see I'm going to just tap the screen here. You're about 650 microns. We dropped down in the 500 range, and we're bouncing around between 500 and 600 microns. So at this point, we're going to do what any normal technician would do. We're going to introduce some nitrogen in, and we'll do a triple evacuation. We'll just go ahead and break it. So I'm going to do two things here. I'm going to slowly isolate these core tools off. In fact, I'm going to probably do this one first. You'll hear a small amount of trap gas coming out of that. And then we'll do the same thing over here. In fact, I think my seal got loose there. One of the things you got to watch whenever you're doing an evacuation when it gets cold like this, you can see these hoses got really stiff. That's a common issue you're going to have because you're 20 degrees out here. But also things like O-rings in here that were normally very vacuum tight and warm ambient air aren't quite as tight now. So now let's take a look at our vacuum here. And we're at about 639 rise rate microns per minute, but we're sort of stabilizing off here. Let's see where we're at. We are at 30 degrees, and where's our micron range at? We're at 3,000 microns. So we're gonna go ahead, we'll break this with some nitrogen. Okay, we're broke above atmospheric, above 760,000 microns, so we're at a good range right there. We'll let that sit for a few minutes here, and I'm going to go ahead and disconnect this hose, just so we're not pulling on the hose here. I don't want the vacuum to get affected by the hose. And we'll go ahead and let that set for a few minutes, and then we'll start back up. All right, so we shut this off at about 14 minutes, and now we're at, if we scrub this across here, we're about 21 minutes in. So we've let it set for a little while, and the nitrogen's probably done its job. If it's gonna do anything, we'll go ahead and open this back up again. So I'm gonna slowly open up this one, and slowly open up this one, and we'll pull that nitrogen back out again in the system. So what we should see is a very fast pull down on this system. And if the nitrogen did some work, we'll see it go back down below the 600 microns that we were stalled at. So we'll give this a few minutes to see where we get. Now you can actually see we're coming down there, so you can see where the graph went up, went across. That is our, where we broke it with nitrogen back to atmospheric pressure. And now we're pulling back down. And you can see we're coming pretty much straight down because that nitrogen is just a gas and will degas very quickly. Again, most of the load right now is moisture, and moisture is going to take some time to remove. And you can see right now we're starting to stall out our turn right at 500, but it looks like we're going to go a little bit below it. So we'll let it run for a few minutes, and that's microns per minute. We're at 520.19, still coming down fast. So let's let it run, and we'll do the next part of our test. All right, so it looks like we're at a nice downhill sweep. We're pulling down about 2 to 9 microns per minute. It's bouncing around a little bit. We're at 349 microns, which is where most people probably would stop and do a decay test, but we're gonna do a triple evacuation just to break this 3 times with nitrogen. So I'm gonna go ahead and do that again. I'm gonna carefully isolate these core tools. And again, think about things like gaskets and O-rings. These elastomers work really good when they're warm, but when they're cold, everything starts to change a little bit. I'm gonna go ahead and open up my nitrogen back up, and we'll break this. Now the Blue Vac gauge does not require a isolation like most gauges. It'll handle up to 1,000 PSI. So we're not gonna damage this gauge here by overpressurizing or anything. So I got enough nitrogen in there to break that, back up the atmosphere. We're gonna let it run for a few minutes and we'll pull it down again. So I never remember to get my screen recording started, but you can absolutely see everything that's happened on this graph, and you can see we've been about another 7-8 minutes or so. I'm gonna go ahead and we'll break this guy in again. So I'm gonna slowly open these up, and we'll pull that atmosphere out again. And I wanna open these slowly because I pressurized it with nitrogen. I just took it out to atmospheric pressure, not really beyond that, so I don't wanna open these up if there's a lot of pressure behind them and blow the oil out of the pump. Now I'm gonna have Val come around here. Let's take a look at our pump oil for just a minute and see where we're at. Our oil still looks very clear considering we're pulling moisture from this, and this is just vapor from the pump pulling a large amount of atmosphere, so it's oil vapor, not really probably water vapor. But we're just now coming down here. We'll give this just a second here, and we'll see how our vacuum's looking. I'm gonna take off this nitrogen hose again, just to cap that off there. And there we go, we're coming straight down again. And we'll see how we fare. So give it a couple of minutes and we'll come right back to you. All right, so we're down to about 281 microns, and we're fairly well stalled out here at about 1 to 2 microns per minute, 0, -1, meaning it's going up and down, because pull down would be making progress, negative means we're losing. So what we're seeing is those small oscillations in the system of just the ice is sublimating vapor, and we're seeing those small vapor pressure changes. But effectively, at this point, we're done. We've pulled down the first time, 1 evacuation, broke it with nitrogen, pulled down a second time, 2nd evacuation, pulled down a 3rd time, and we're at 281 microns. So let's go ahead and let's do a decay test. Again, I'm gonna very slowly close these 2 off, just because things get a little bit wonky when they're cold. All right, so I got those 2 closed off there, and you can see we're already up to 1,200 microns, and we're climbing very rapidly. So if you just got it down to 300 microns and isolated, a lot of techs don't do a decay test. If you had just gotten it down there, you'd be in trouble right now. And let's see what our saturation temperature is. We're at 4.4 saturation, 4.5. My guess is we're gonna equalize right about the atmospheric temperature that we have here, about 20 degrees when we're done. And that's because the ice is still in this system and we're not making good headway on there. So this system is still very wet. We're gonna give it a few minutes to just sort of flatten out, and then we'll pull it down again. All right, so the vacuum gauge is right now at 2,400 microns. You can see we're sort of flattening out right now. We're at a 65 micron decay rate on there, which means it's still wet. Now what I'm going to do, since we passed the decay test, I'm going to go ahead and add nitrogen to this one more time here, and we will again break it to atmosphere and let it set for a few minutes. And the only reason I'm taking this hose on and off is because what I don't want to do is evacuate with this hose in place, because it'll compromise the evacuation. Crack this tank back open again, and we'll break this to atmosphere. And all right, we're at high HP here, which means that we're at above 760,000 microns. Just giving a little extra here. And we'll shut this off, disconnect our nitrogen again, and we'll let that set a few more minutes, and then we'll open those valves back up again. All right, so it's been, again, about 7-8 minutes. We let the nitrogen just sort of rest in there and do its work. Normal time, people wait 10-15 minutes, a couple minutes more. It's not going to make much difference in this case. We're going to go ahead and pull this down again, so I'm going to go ahead and open these up slowly, just to make sure that we don't have too much pressure in there. All right, we'll let that pull down and see where we fall out at. So let's give it a couple more minutes, and there we go, we got a nice straight down pull down again. So a couple of things I just want to point out here. The nitrogen, when it's sitting in here, the moisture is still degassing. All right, it's still degassing, and the nitrogen will help carry some of that out as it flows out of there. But what I want to show you is we're not making significant progress on dehydration, because it's so cold out here at 20-some degrees out here, and the piping's cold, everything's cold out here, and the ice is cold, and the ice is actually getting colder, because again, as the ice sublimates, or as it turns from a solid to a gas, it absorbs heat from the air around it to do so. And so the two ways that we make this ice sublimate faster are we either warm up the system, right? We warm up the whole system, or we lower the vacuum pressure. Now, for a lot of people here, you've got to admit, we're down to 370 microns. If you hit 370 microns, most of you out there would say, you know what? There's no way we got a leak at 370 microns. Go ahead and cut it in. We'll cut in a charge. We'll do another decay test here, though, in a few minutes, and let's see if that moisture still is reigning in this system. All right, so we're down at 240 microns, and I'm just going to scroll ahead here. We've been on for 1 hour and 4 minutes with the TruBlue hoses on there. We've been below the target for about 6 minutes and 14 seconds, and our ambient temperature at the gauge there, which again, we're in the sun here, is showing about 36 degrees. I believe we're close to 20 degrees out here right now in the Mogador area. And our evacuation rate's pretty well stalled. We're down to between 0 and 1 micron a minute, meaning that we're flatlined again, right? Now what I'm going to do is I'm going to leave this system run, and we're going to leave it on here for an extra hour. I'm just going to leave it out here and go, and we'll come back in an hour and we'll do the decay test again and see how we look. All right, so we've been on the vacuum pump for 2 hours and let's say 20-30 minutes here, and we are at still an ambient of 34 out here on the gauge anyway, and a saturation temp of -39, and ultimately we're at 135 microns right now. So we're way deeper than almost anybody would go this time of year. Now I'm going to go ahead and we're going to do a decay test. So I'm going to isolate this off. I'm going to hit isolate on the start decay test on the graph here. And I'm going to slowly, again, close these off here. And slowly close off the other side here. And you can see we have a rapid buildup of vapor pressure as soon as these are closed off. And we'll let this settle out for just a minute. Now most people, again, they're not going to take the time to do this decay test. So they would just start this system back up and go. Right now we're up to about, let's say 421, 550 microns, from 100 to 500 already. Climbing up very quickly, but we're starting to stabilize off. Let me see what our rise rate is here. Our rise rate is 228 microns per minute, 218. So we're slowing down, but we're still have a lot of moisture in the system. So we'll let this run for a few more minutes and go from there. But now what I'm going to do is I'm going to stop this process, at least the evacuation piece, and I'm going to take this in our shop and we're going to let it warm up and we're going to see what the actual level of moisture in the system actually is. All right, so we're back inside and it's only literally been since I isolated it off here. I isolated it off at 2 hours and 11 minutes, and we're up at 2 hours and 18 minutes. So it took me about 6-7 minutes to disconnect everything and walk from here to inside. But you can already see we are at 1,328 microns. So we went from a vapor pressure of in the 20s or 30s, I think, 136 microns. 136 microns is how deep we got the vacuum. Anybody in their right mind would say there's no way that system has a leak, and you're 100% right. It's soaking wet. And that's the problem. This is the problem with cold weather evacuations is things can look one way, but as soon as the system warms up, it's full of water. This is why your system's gonna fail a year later. This is why we're gonna continue to see these problems in our industry unless people start to understand that you just can't do certain processes certain times a year. All right, so we are pretty much wrapped up with this little experiment, and you can see right now we're at about 2,600 microns, right in the wet range, right where I told you it would be. And this is what would happen if we were to actually do this evacuation in the winter, there was any moisture in the system, even in 2 hours with oversized hoses on an evacuation that typically takes 6 minutes on a dry system, even in 2 hours we can't get the moisture out of the system, even though we got it all the way down to 136 microns. And that's because moisture removal is a vicious cycle. Vapor pressure is generated by temperature of the ice. As that ice started changing from a solid to a vapor, it kept getting colder and colder and colder. The deeper the vacuum got, the colder the ice got. The colder the ice got, the lower the vapor pressure. This cycle does not stop. And this is why it takes so long to get moisture out of a system. And you can see, even though it looked like our triple evacuation might have helped, if we had just given it time, we would have had the same results. The interesting thing here, if you look at that graph, it goes down at a very complementary angle. I mean, straight down. Now that one little drip down or dog leg down was because I lost connection from the gauge when I went in the shop and I came back outdoors and reconnected again. That's explainable. But overall, what we're seeing is a very slow pull down due to that moisture. And this is again why we don't want to do evacuations in the winter. And this is again why if you do, you're going to end up with a wet system. If you're just curious what these tools are that we're using here, just to summarize here, this is the AccuTools BlueVac Pro Gauge that interfaces with the BlueVac app. That's what I did all the graphing on. The entire vacuum rig here is an AccuTools professional kit with 2 hoses. It comes with a couple of core tools, adapters, and ties in real nicely with this Testo 552i pump. And this whole system worked really flawlessly for what we're doing, but it also really makes your job a lot easier when you have the right tools to do it. And you can buy all those tools at TruTech Tools. We've been working with them for years on this stuff, and they keep all these tools in stock. This is Jim with MeasureQuick. Thanks a lot for watching.